Just completed chapter 2 and learned so much about matrix and all the operations that involve the use of matrix in production. We're now in chapter 3, which takes another direction of utilizing functions to determine optimum production levels and profitability. And in this case, we're talking first as a prep, graphing with linear inequalities. Like the title suggests, we'll review concepts that involve the shading of areas of feasibility. Feasibility in that, yes, we can be in that realm and still qualify according to needs or supply or demand of those cases. So let's first start with a linear equation. In a linear equation, we have y equals some mx plus b, or any function that has an independent x that drives an output. That's known as the y. Well, a linear equation means we have an equals, but we're talking inequalities. So here, the equal symbol will be replaced by inequality symbols. And we'll review that in a little further down in this lesson. The graphing approach. All right, so this is going to be important as to how do we draw or connect or read even these graphs. Well, we approach the linear equation by x and y intercepts. Or the use of y equals mx plus b, where b is the y-intercept, and m is the slope, which is rise over run, telling us what movement we do after we plot that y-intercept. All right, and now comes the inequality symbols. And these you've seen all of your math career, starting with, believe it or not, we did it in second grade, where we compared numbers. And in this case, we're saying this one, which says greater than. And what this implies is does not include the digit reference. So it is a dashed line. So this one is a dashed line. Greater than or equal to does include the values of that line. So this one is a solid line. And the values are greater than that line as the above. And then we have this one, less than. And again, it does not include the line. But all values below the line. Well, that's a funny below, isn't it? And then we have its companion, less than or equal to. And that this is a solid line. So those are our options. And we're going to talk about approaches of what makes sense to you and what works. Well, what happens in finding values that fit the linear inequality equation? So we need, what this question is, where do we shade? Because we know we have limitless opportunities to fulfill the request of that inequality, just in different directions. So what happens here is we use a test point x of 1, y's of 1 that is not on the line to test if it is true or false quality equation. All right. So that's the big hubbub. All right. So here we go with an example. And here we have a greater than or equal to. So we're going to have a solid line first. And we have a simple line. And then so we're going to do a chart. Or use y equals mx plus b, whichever one you want. So let's look at that. So here's our x value and here's our y values. And they're just ordered pairs that we solve the equation for. And we know our equation is y is greater than or equal to x minus 8. So I'm going to let x equal 0. So y is negative 8. That's one ordered pair. Then I'm going to have y equals 0, and then x is 8. And then I could choose any other point, but that's good enough. So we're going to graph this. 0, negative 8. So this is down here. And then I have 8, 0. All right. And I'm going to draw a solid line through that as best I can. Now remember, I'm using my tablet and I'm not always good with it. All right. So now that I have sketched the line, need to know where to shade. All right. So to know where, I'm going to choose the test point 0, 0, because it's easy. And I'm going to put it in for the equation. So I'm going to put 0 is greater than 0 minus 8. 0 is greater than or equal to negative 8. And that is true. So we shade in that region that qualifies, that includes that point. Well, could I have used another one? Sure. Let's try another one to verify that is true. So let's try the point. Just for grins, I'm going to do this one. And that is 7 and negative 3. All right. So I'm going to insert it into the inequality. And I have 7 is greater than or equal to, and I'm going to have a negative 3 minus 8. And I'm going to have, oh, I got it backwards. Oh, gosh. Boy, is it, I can't blame it on COVID. It's just Elmo Wislinski. So this is going to be negative 3 is greater than or equal to negative 1. And that is false. And sure enough, it's there. It's in the unshaded area. But you really only need 1 point, because these are definitely not hard. Now this one, we have to first place it in y equals mx plus b, because we'll do this one according to that. So I have 6x minus y is less than 9. I'm going to subtract the 6x, because I treat this as a linear equation. Minus y is less than 6x plus 9. I'm going to divide by a negative 1. If I multiply or divide by a negative 1, the inequality flips direction. All right. So here we're going to do that. M is 6 over 1. Up 6 over 1. Our B is negative 9. So we're going to start at negative 9. And we're going to go up 6 over 1. All right. It's a very steep line. So I'm going to place the line. And the computer makes it really easy. And we're going to do the test point 0, 0. All right. So I'm going to use my original. 6 times 0 minus 0 is less than 9. And I'm going to have 0 is less than 9 is true. So this means I have any value that's found in the graph area above that line. I'm going to do a test point again, and this time I'm going to use this one. I'm going to do the point 4 and 0. All right, point, well, my pen is trying not to write for some reason. My screen must be tired. And I'm going to put it in my original function. 6 times the 4 minus 0 is less than 9. 24 is less than 9 is false. So we have done good math. This is not in the answer set. All right. So right here, it's asking us to graph the inequality. And here we have not a function, but a undefined slope. And this one's a dashed line. So let's do this one. And I don't know where my graph, oh, it's down here. Okay. We're going to do this one as x equals 7. I mean, greater than 7, sorry. So in this case, I know that x is always 7 because we treat it like an equation. And this is going to be a dashed line. So I can put 0, -4, doesn't matter, and 1. There you go. So I'm going to do that. I'm going to go 7, 0. It's right there. Then I'm going to go 7, -4, and it is right here. Then I'm going to go 7 and 1, and it's right there. Then I'm going to try to draw my line and understand it's supposed to be very straight, and of course I'm a little off. And it's going to be a dashed line, so I need to erase some of it. All right, there's my dashed line. All right, and now I'm going to do my test point. And again, I'm going to use 0, 0. Okay, so if x is 0, is it greater than 7? No. Therefore, we're shading everything to the right of it. All right. This was false. Well, let's try one over here. How about this one here? This one is 10 and -4. All right, so 10 is greater than 7, and that is true. All right. So now we're going to graph another one that is equal to, and that is, x plus 2y is greater than or equal to -2. All right. So let's see what happens here. Might want it in y equals mx plus b. So I'm going to have 2y is greater than -x minus 2 and equal to. I'm going to divide every term by 2. Y is greater than or equal to a -1/2 x minus 1. All right. Now on this one, I can use my slope, and it is a solid line, so that'd be a good one. So I'm going to put my b is -1, and my m is -1/2, which is down 1/2. All right. So I'm going to go to -1. Excuse me. That's my y-intercept. And I'm going to go down 1/2, down 1/2. I'm going to take my line and go from here through there. Yeah, it's pretty close. I can see that 0, 0 is free. So I'm going to go in the original. I'm going to put 0 plus 2 times 0 is greater than or equal to -2. 0, in fact, is greater than or equal to -2. It is greater. So we are saying our value of the inequality graph is shaded on top of the line. All right, it's on top of the line. So now I'm going to take another point, and I'm going to do 0, -6. All right. So remember my equation. I'm going to have 0 plus 2 times -6 is greater than or equal to -2. -12 is greater than or equal to -2. That's false. It is less than. The larger the negative number, the less it is, further away from 0 that it is. So we want to graph this last one, which is y is less than or equal to -1. This is a solid line, and it is a function. It's a zero slope. So I have x and y is -1. So I can write any number for x, and y is -1. So I have 0 and -1, and then I have -4 and 0 and 4, and I'm sorry, not 4 and 0, -1, and I got it on the wrong line. And then I will draw my line. The horizontal line, and it's solid. So we're going to use the test point of 0, 0. 0 is less than or equal to -1, and this is false. So it's not at this point, it is below. So we're going to shade everything below, and the program will let you do that easily. So long you tell it where to shade on the line, it'll work. I have some residue left. I'm sorry about that. And let's test it. I want to do this point right here. Let me do 4 and -3. It's our test point that it does work. So y is -3 less than or equal to -1. True. So we are fine on that shade. All right, now we have a compound entry, and each one is taken independently. So let's see what we have. All right, and it'll be probably in between or above one or the other. It depends. So we have, oops, let me do the blue. X plus y is less than or equal to 4. Now remember, we treat it as a function of intercepts. If x is 0, y is 4. If y is 0, x is 4. So we're going to have this particular line at 0 and 4, and 4 and 0. And I'm going to take my line and draw it. All right. I'm going to start the, oops, no, that's not good. I'll do it again. I think it's right there. Oh, stop it, Alma. All right, let me get going here. Go, 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 go. I think it's right here. Yeah. Let me go like that. All right. Okay, now we're going to test our point. And we're testing with 0, 0, because it's obvious it's there. And we either shade where it is or not shade where it is. And we're putting, and this is a solid line, so at 0 is less than or equal to 4, and it is true. So we're going to shade going down. And this gets us a precursor to what we're going to be doing for optimization. All right, linear programming. All right, so now we're going to do the next one, and we're going to do that one in black. And that one says x minus y is greater than or equal to 6. Again, we're going to do our t-chart, 0, and I get -6. Then I do 0 here, and I have 6. So I'm going at 6, 0, and -0, -6. Now I'm going to draw my line. Going through the 2 points as best I can. And I like that. Okay. So this is my Y2, and this guy is my Y1. I'm going to do 0, 0 again for my test point. And so I have 0 is greater than 6, and that is false. So it's not above, it is below that line. So I'm going to use the blue. And the blue and the yellow turn green for where it is shared. So this side is shared by both. All right, now that takes care of this lesson. It's not hard, it's just getting you used to plotting and knowing if it's a dashed or a solid line. Thank you for listening, and do your homework.